Welcome back to another containerization crash course video. My name is Jeff Krakenberg, and today we are going to be going over pulling a new Docker image, running it, updating something in it, but really just creating a file, and then kind of recreating an image based on our new container, and we'll talk about that as we go through it. But first up, I have docker search CentOS typed into my terminal here, with some spaces in between, of course, to make it work. And what this does is it's going to go out to the available repositories and pull down anything that has that tag in it. If you're not familiar with CentOS or Community Enterprise Operating System, it was, keyword being was, a really popular Linux distribution as a version of RHEL, Red Hat Enterprise Linux. I won't go deeper into that today, though. And so we could go ahead and just grab the CentOS, but you'll see there's also some custom versions or updated versions, things that have specific configurations built onto that CentOS. I'm going to pull the systemd enabled container, and how we can do that explicitly is by going docker pull CentOS /systemd, just match the name. This is like going to the grocery store and picking out what type of instant ramen noodles you want to have. It is going to pull down the latest version of it and host that locally. It will take a second to download, especially if you are running a bunch of things at the same time. But eventually you will have your image downloaded, and then that image can be used to make a container. And we'll get into that as soon as this download is done. Alright, so now we have that image downloaded. We can double check by going docker images, and we'll see we have the Ubuntu and Hello World from the last video, as well as this new CentOS systemd. We can create a container based on that image, same way we did last time. Docker run it CentOS /systemd, just match the name, you don't have to put latest, and then bash to get our shell. This would be, oh man, my apologies, I'm getting over an illness. This would be taking the image and running it as a container. The image is, like I said, like your preferred version of instant ramen noodles. As long as you have that image, you can create a full container. Docker run is then like as you are cooking those noodles, getting them ready, and then you can do something inside of it, like maybe, let's see if we do echo, and I'll just say hello into hello.txt, and then cat hello.txt. So that would be like adding whatever garlic or chives or mushrooms or peas, whatever you guys, egg, put into your instant ramen noodles. Now we have a thing that we've added to our container to have it be what we want. While this is just a little echo, you could do something like install SSHD or install and configure Apache. And like we saw in the last video, if I exit out, that isn't as available, right? So once you have your container and you use it, if you just exit out and call it there, you will lose all the things you did unless you commit them. So if I do docker commit and say added hello.txt, and then from the author of Jeff K, and then I'll say Jeff K, we'll call it CentOS hello. And what this is saying is that Docker, I want you to commit this Jeff K CentOS hello. What we changed was I added the hello.txt, and this is by the author of Jeff K. The reason why you do this is because in the field you will never be dockering in a silo. You will be working with repositories, whether they are public, private, or team-based. So you don't want to lose those. And this is going to essentially create a new image based on the changes we made in the container of the original CentOS systemd image that we started with. I'll let you guys come up with the instant ramen noodles analogy there. I'm only good at like creating 2/3 of an analogy. So if I run that, error response, no such container, because I did forget a little bit of information. We have to specify who is building it or where it's building from. So if I do docker psa to grab all of them, we'll see that we have a bunch of stuff here, but about a minute ago I had this guy. So I'm going to copy the selection, and that is compassionate leave it. I'm not going to make any jokes about the names this time because that's how Wizardly Chebyshev is still stuck in my head. So I'll just paste that right in here. Delete the extra characters because I don't know how to copy correctly sometimes. And now we'll see we have a hash of that. So we did docker commit, added, we called to the specific container ID that I forgot to do that first time, and then I added that. So now if I do docker images, we'll see we have CentOS systemd as well as Jeff K CentOS hello. So now if I do docker run it Jeff K CentOS hello bash, and then ls, we'll see I have that hello.txt, cat hello.txt, there's my hello. Whereas if I were to have just ran the same CentOS that we started with, and did an ls, we don't have that hello.txt. So that is where that comes in. Now, when you start working with more and more images, you are going to need to be aware of one last part on that far right side, U for in use. You cannot just get rid of a image that you are currently using a container of, even if it's not actively in use. And so what we need to do is we need to get rid of those containers. So if I do docker RMI and I try and get rid of that CentOS systemd, the one that's not my hello, it'll say, hey, you can't do this. Container is using its referenced image. So if I copy selection, docker rm, and then paste that selection, that's gone. Oh, we've got another one. As you guys can see, there's probably a quicker way to get rid of all of these. If you want to learn a little bit more, go beyond the scope of this video, I believe in you. But then, after getting rid of the two containers that were referencing that image, I can now get rid of that image. And we'll see right there that I now have only the three that were left. But you'll see I still have those in use. So what if I did docker ps, I don't have anything active running, docker ps a to see everything. You'll see I have all of these in here. So what if we could find a way to grab all of those container IDs and kill all of those container IDs at once so that we don't have anything running in the background using up our resources? As a hint on how to do that, if you want, you would need to docker rm and then do a little bit of fancy docker psa pipe something in there. Probably just awk and then print number 1, if I had to guess. And then that will pull each of them. So I did come through and everything except the first line, because of course there isn't a first line. So now let's go ahead and docker PSA. I have nothing going on. So now if I docker images, I have nothing based on those. So I can clean up that hello world latest that I'm never going to touch again. And I can docker RMI my Jeff K CentOS hello. And now that's gone. If I docker images one last time, all I have left is the Ubuntu container, which we will use in further containerization crash course videos. So don't delete that one unless you want to pull it again later, but it's really quick to do that anyway. And so that is just a bit of disk management at the end of our Docker video. Thanks for being here.